In our previous lesson, we saw vectors and their properties. We saw the modulus of a vector and also the direction of a vector. In this lesson, we will see the components of a vector. That said, let's get into class. Now, in our last lesson, we explained that a vector has both magnitude and direction. Now, if I have a vector this way, to exert the direction of this vector, I'll either place this vector in the two-dimensional plane or the three-dimensional plane. Now let's use the two-dimensional plane. Let's use the x-axis and the y-axis. Here's vector r. Here I have my y-axis and here I have my x-axis. Now for this vector r, you understand with me that this vector r must have two corresponding sides. That is, it must have a y component and also it must have an x component. These are the two major components of the vector. The vector has a component along the x-axis and also along the y-axis. The same thing happens if we're talking of a three-dimensional plane. In a three-dimensional plane, the vector will have three components. It will have along the z-axis, along the y-axis, and also along the x-axis. But we have it in a two-dimensional plane, we have it as x and as y. But when I have it in a three-dimensional plane, we have it as x, y, and z. Repre- to represent vectors, one easy way of representing vectors is we can represent vectors as vectors like my r now. I can easily represent it with as x and y, and I can also represent it with as unit vectors, so that as the unit vector my r can easily be represented as xi plus y, so that cos theta will be the same thing as x over r. That's equals to the adjacent over hypotenuse, and sin theta will be the same thing as y over r. That is the opposite, my opposite over hypotenuse. So that in situations where I have only my x and y components, I can easily find what the modulus of these vectors would be like. So that finding them, you have that r squared will be equals to x squared plus y squared. To help us understand this better, let's take an example. My example says I should find the modulus of 3i plus 4j. Let's represent it with a diagram. Now my I will be the x component, which is here I'll have 3, and my 4 will be the y component. So that here I'll have 4. So that here is r. So that from here my r squared will be the same thing as 3 squared plus 4 squared. My r squared will be the same thing as 9 plus 16. R squared will be equals to 25. R obviously will be equals to 5. Let's see a second example. If R1 is equals to 7i plus 3j and R2 is equals to 2i minus 5j, R1 plus R2 will be the same thing as 7 plus 3 is 7i plus 3j plus 2i minus 5j. Let's collect like terms. That will be the same thing as 7 plus 2i plus 3 minus 5j. So that this is equals to 9i minus 2j. Now we're asked to look for the modulus of this, so that r, which is the modulus will be the same thing as the square root of 9 squared minus 2 all squared. R obviously will be the same thing as the square root of 9 squared, that's 81, plus 4, which is equals to the square root of 85. Now to find the direction cosine will come from cos alpha, which is equals to, that is 9, that's the x component, that's 9 over r. That's equals to 9 over square root of 85. Now from here, now I can now deduce what alpha will be, which will be equals to the cos inverse of 9 over square root of 85. This help you understand how to find the components of a vector. If you have further inquiries, please do not hesitate to use our comment section. Thank you and see you in our next class.